Alright, so let's talk about the atomic nature of matter. So assuming you have a given piece of matter, so let's say we have a spherical ball. So if this spherical ball is divided into smaller and then smaller pieces, so a point will come where one would have an invisibly smallest particle. So it is said that this smallest particle has the same property as the spherical ball here. It has the same property as the parent matter. So the smallest particle that cannot be further divided is called an atom. So several theories have been put forward to explain the properties of atoms, but Dalton's atomic theory is the most foundational. So let's talk about the Dalton's atomic theory. So the Dalton's atomic theory states that all matters are made up of tiny, indivisible particles called atoms. So what Dalton is trying to say here is that, let's say we have a spherical ball again. So Dalton says that this spherical ball is made up of tiny particles that cannot be further divided. So this statement is actually no longer true. So the occurrence of subatomic particles, proton, neutron, and electron, has made this statement not to be true. And this as a result of experiments. No further experiment prove that atoms of elements are actually made up of subatomic particles, protons, neutrons, and electrons. So another Dalton's atomic theory is that atoms can neither be created nor destroyed, but the occurrence of radioactive reactions such as nuclear fission and nuclear fusion has actually modified this theory from Dalton. So nuclear fusion actually leads to the creation of atoms, and nuclear fission leads to the destruction of atoms. So Dalton also came up with another theory that atoms combine in simple small whole number ratio. So this is actually true for simple inorganic reactions. So but for complex organic molecules like glucose, this statement is not true. So another theory put up by Dalton is that atoms of the same element are identical and have the same mass and chemical properties that are different from the atoms of another element. So looking at the schematic diagram here, element A, the atoms are identical. But when we try to compare the atoms of element A and B, they are different. So from the conclusion of Dalton, it is clear that the atoms of element A and the atoms of element B have different mass and chemical properties. So this has been modified by the presence of isotopes. So these are different isotopes of oxygen. So they have different masses. So despite the fact that data states that atoms of the same element should be identical, so despite that theory from Dalton, these atoms of oxygen are actually not identical in their masses.